Okay, so I wanted to start this episode on how to subnet a network into bite-sized pieces so you can use it for different networks, basically, as stated. And I'm using a packet tracer here. This packet tracer is already got the instruction for us, and it's a little weird because it doesn't do the traditional VSLM, which is variable VLSM, variable length subnet mask. It kind of just wants you to cut the addressing block into chunks that are all the same size, which isn't really the way you do subnetting, but it can give you the idea of how to do it. And it'll give you the full idea on how you can use the most out of your subnet if you wanted to make every single subnet the same amount of hosts. So let's kind of run through a few things. In this I'm going to go through how to do the packet tracers. So basically it'll be, if we want to do this, I want to go to here. Nope, that's not what I want to do. So real quick, let's go over the basics of subnetting first. So the first thing you always want to do, depending on the network or networks you will have, is count the number of hosts for all subnets to make sure your address block will work. This is your address block for this lab, and this lab is 6.7.5. This is also a Class C class full. Now, if you're a /8, 16, or 24, that means you're in a class and you're a class full address. If you're subnetting and using any type of VLSM, variable length subnet mask, then you are going to be classless. Okay, so usually you start with a class full and end with a bunch of classless that are taking chunks out of that address block. The second thing you want to do is you always want to start with the subnet that needs the largest amount of hosts, then the next largest, and so on and so forth. So largest to smallest. That way, if you need to add on later, you can. You don't want to go smallest to biggest. It really doesn't work, and you can run out of addresses fairly quickly without even realizing it. Every subnet you want to allow 2 extra addresses per subnet. Network address and your broadcast address. And as you can see down here, this is your network address, your host address, and your broadcast, and then subnet mask. So I'll get more into that in a moment. And then finally you want to think of expansion when assigning IP addresses to hosts. What that means basically is if you have 30 hosts or 30 endpoints or 30 computers in this case that need IP addresses, you don't want to give it 32. Yes, it'll work. You'll have just enough, but you can never add another person or computer or anything on there. So maybe you want to go into 64. So these are the basic ideas of subnetting, and I'm going to go over those in detail with these little bits right here. Let's go into a little different area. So this right here, it should be it might be a little bit hard to see, but hopefully you can read it. So basically, to give you an idea, this is the numeral values in base 10 basically. So our numbering scheme. 128, 64, 32, 16, 8, 4, 2, 1. So this is a 32-bit IP address right here. On a sheet of paper, you have 32 lines going down a college rule. So I learned to put the spaces for all of them and write them. This is kind of a memory dump, so you can come back to it quickly. And this allows you to basically, here's your numeral values above your bit placements. So there's 8 or an octet for each one. This is your first octet, second octet, third octet, fourth octet. And then finally your subnet mask. So if you had a /1, /2, /3, you can continue, and depending on the number of ones, you could figure this out fairly quickly what your network address is going to be. So 25 bits of network, and then what your host can be as well. And you can do the calculations on another separate piece of paper. In this case, I'm making the assumption that you understand how to do binary conversions, and I won't be going over that necessarily. I just wanted to show you the dump sheet. Down here is another part of the dump sheet. So I've memorized all these. These are your subnet masks. So these are all your slashes, also in correlation to your slashes here. Remember, class A, B, and C. So B being here, C being here. So if we look real quick, based on the available hosts, so if I have a slash, let's just take /24 right here, which means this up to this bit is a 1, all down to here is your network. This is your host address, which means you can use all of these bits for your hosts, which it technically equates to 256 dropped by 2, so it's 254. And then the next one is going to cut that in half. So you open this one up, you have this amount, which is 128. So now you have 128 hosts based on a 25 and a 25. So you'll have ones all the way back. These will be networked. And this is host. All the way down. And for the subnet masks, though these correlate with each other, this is excuse me, this is a 192. So all you have to do to get the subnet mask is understand these are 255, 255, 255 for a class C. Anything that's going to be networked up to a point is going to be a 255. As stated, I did B as well, and your B coming up to this point, since these are all ones, 255, 255, and then these are your hosts until you start masking. So the other thing here is, so if you have a 255, 255, 255, 128, I know it correlates with this, and that's why I want to move down one more. So you have a /26. So you have a 1, 1, and then 1's all the way down. So you have 26 ones, or 26 ons of binary code. And the rest of this, these ones, 27, 28, 29, 30, 31, 32, are all open for hosts. So to get the mask, you would add 128 and 64 together, which makes 192. Then if you did network up to here, borrowing that many, you would do 32 plus 64 plus 128, which comes out to 224. And you can continually go down. I understand this is cut off, but this is going to give you a better idea. The other thing is, for your networks for a class C, I'm not going to get up into the network region up here because it gets a little confusing. But basically it says networks depend on the class address starting point. So if I'm starting with a class B, your class C may be a little, like, it's going to be the same, but it can actually switch for your B if you start at B. So I don't want to get into it too much right now. It's not really needed, because most of the time for now, there's two different methods for subnetting for class B and class C. So you have to kind of learn this method first before you run into this method. But to keep it simple, there's your hosts, and if you notice, they go from the bottom. If you're at 30/32 or all 255s, you have one available host technically. Then it doubles. Then it doubles as we go up. Then it doubles. Then it doubles, doubles, all the way up. That is the scheme that you can, basically, if you were to dump this out quickly, it continues to double, and this will help you immensely. That way you're not sitting there trying to do binary code and trying to figure out host numbers. When you're making subnets, you can do it fairly quickly with this system. The other thing is your networks is based on the networks that are actually past the class C. So if this is open, you have a 1 and a 0 at a /25. That means this is your only network address past the 24 point. So technically, you have 1, which is one network, and 0, which is the other network. So you have 2 networks available. And you double that as you go, because this is, again, it all doubles again. So it's the opposite of this. Pretty simple. Okay, so with that being said, we can use this to figure out what subnets we're going to use based on the hosts now. Again, to do the binary code, I'm not going to go into it at the moment because I'm making the assumption that you understand binary code at this point. So, real quickly, there's also cheat sheets out there that give you the binary code, but not the calculations, and they give you the mask itself. As I showed you before, they give you the host number, they give you the address, subnet /, and then they give you what type of class it is. And this is, I'm gonna have to remember what this is, but it's just the wording. It's an acronym that I can't remember at the moment for not being class. And that is the OSI model. Okay, so let's get back to where we were. So in this packet tracer, I am going to teach you really quickly, and then I'll start in the next video the actual packet tracer itself and how to figure this out. But I want to just read through this and explain how to check and do a packet tracer. So when you open this up, you have all of your components here, or devices, intermediate devices, and endpoints. So you just simply read through this. It just makes a state that it does not include an addressing table. You have to make it. You have to subnet an address space per given requirements, which is the address block we saw. Assign appropriate addresses to interfaces and document, which you should be writing this down anyway. Configure and activate serial and fast Ethernet and serial interfaces. Test, so ping, and verify configurations. Reflect upon and document network implementation. You should be doing this, writing down most of this anyway at this point, because this gets kind of in detail. You can read all this, but they give you one address block to subnet, and you got to figure out the logical addressing or subnet schemes to fit the amount of hosts that they give you. So you'll be given a 192.168.1.0/24, which is a class C address. It's classful. Okay. And you need, basically, your network consists of 3 different subnetworks that you need to subnet. And so this one, if we read here, one requires 15, one requires 30, and then the other one is a link between the 2 routers. So it technically only requires 2 addresses. So remember, you have a broadcast and a network address. If I can find it. You have a network address, which is the start of that subnet, and you have a broadcast address, which is how the actual address used to broadcast out to that network itself. It's not the main broadcast address. There's two different types of broadcast address. There's the Subnet Broadcast address, which will only do the subnet, and then there's the actual broadcasting address for the entire network, which is 255, 255, 255, 255. That'll send a broadcast across all subnets, while this will only send a broadcast across one subnet that it's in. So the way I have up here is called variable length subnet masking. And they said we're starting again with this address block. Well, if you notice, our first network address starts with this address block. So that's your first hint. The address block, the very first subnet, is always going to start with the address block that you're given, because you have to start somewhere. From that point, we'll get into it. So, if we want to dig a little bit deeper, which we do, because that's what we do, it just states here, notebook, separate piece of paper, following answers, how many subnets are needed for this network? Well, they've given us an answer, technically 3. So, if we look at networks, this is a network, this is a network, and this is a network. 3 networks, or subnets in this case. How many subnets are needed for this network? What is the subnet mask for this network in dotted decimal format? Well, you just have to think about this. I'm not going to go too far into all these because we're doing it anyway. What is the subnet mask for the network in slash format? So again, we've been going over this. You just have to think about the questions. How many of the usable hosts per subnet? Again, that's where these come in. So let's do a little bit of fun math here. Actually, there's really not too much math involved here. So it's simple. So you've got 15 hosts. And if we look at our wonderful diagram I have, or not diagram, but notepad, that I'm losing my mind right now. There's just a lot of stuff here. So, based on this, if we need 15 hosts, which one of these numbers will fit into it? Well, the problem is, again, with 15 you need a broadcast and a network on top of that. That would make 17. So technically, 16 is not enough. You would need a 32-bit address. That's where it gets a little tricky. So you wouldn't obviously go with this. You would have to go with the 32. Because again, just add 2 to whatever they say the host is, because you need those 2 addresses as well. So the next one says 30 hosts. Technically, you always want to give a network a little bit more, but in this case they want it to be very specific. In this case, the next one up from 16, remember, if we need 30 hosts, add 2, so 32 hosts. Does that match up with anything? Of course it does. It matches up with this one right here, so you're good to go. Which, so far we're at 32 for both, so it's a /27. Or 27 bits being used for network, while the rest are used for hosts, and that's how you get the calculation. The hosts add up here, and the network add up until the point of the class C, because that's where you start with your block. So, finally coming back one more time, a link between a router R1 and R2 will require an IP addresses at each end of the link. Well, I see 2 interfaces, and for a point-to-point, which is what this is called, a point-to-point serial, you only need 2 addresses, one for each interface. you still do need a broadcast and a network as well, so you need 4. We go back one more time. 4. And this doesn't have to be bigger because it doesn't get any bigger. It's just simply point to point and never changes. It's how it's built. So it's a 252 for the subnet mask and a /30. That's for any router to router serial. Always. Doesn't matter. So that's the easy one. So moving on. Finally, so they want you to basically write all this down, and that's what the other sheet is for. And it says assign second subnet to network attached to R1. This is the network attached to R1. Assign third subnet to a link between R1 and R2. This will be the third subnet. And the fourth subnet to the network attached to R2. Wait a second. I just said there was only 3 subnets. Why is there a 4th? That's where the tricky part comes in. This little thing. Do not use variable link subnetting. So that means that they have to be the same size, all of them. And to do that, we know this is 32. We know this LAN is 32, which is, again, if you read R2 connected to R2, which is this. Remember, these PCs, they're just a placement holder. We're not going to physically put 32 hosts on here. It's just kind of messy and not worth it. You just simply want to give them an address and just make the notes that this will be 30 hosts. Well, technically this one's 15, this one's 30. That's all. It saves time. In the real world, you'll actually have 30 different computers or whatever endpoints here. But so we have 3 different addresses. That's your third, but they're talking about a 4th subnet. So let's finally address that, and then we can go through the addressing scheme and actually do this. So I made 2 different scenarios. The first one up here is actually based on how you're supposed to do it, so you can save address space. The second one is for your learning experience, and why they're doing this, they're making the assumption you will make a mistake and only sit in one type of subnet size, which is fine because this gives you a better idea, because I went all the way up to an 8th subnet to show you where the end of that is. I'm using every single IP address in that class C, and it makes up to 8 subnets. And when I come back to this in the next video, I will explain the difference between these 2, and then we'll start assigning them to the computers and devices themselves.